Okay, so this lesson is lesson 6.02. It's on permutations, and the problem set for this lesson is 1 through 24 on page 446 of the reference guide. So again, please make sure to do that after you watch this recording. Okay, first thing to teach you about here is what a factorial is. A factorial symbol is the exclamation mark. So some of you may have, like in a chat, said the answer is 4, and you put an exclamation mark because you're so excited that you're right. Technically, that actually means 1 times 2 times 3 times 4. So the factorial is a shortcut for multiplying all the numbers from 1 up to whatever that number is that you wrote. So that's why you'll see here 3 factorial is 1 times 2 times 3, because it's 1 times all the numbers up to 3. So like 10 factorial would be 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. Factorials get really big in kind of a similar way that exponents get really big. Okay, so a permutation, the reason why we have to talk about factorials first is because permutations are going to use factorials. A permutation asks the question, how many different ways can I arrange these things, whatever these things are? Or how many different ways could I choose to place things or people in a group? So it's kind of like if you have a ranking. If you had a ranking system, the permutations would be how many different ways can you rank this or rank these things. A key idea, and this is probably the thing that I focus on the most in my own head, is that in permutation, the order of the objects or the order of the things that you're choosing matters. It matters what order you put things in. I find for myself that it really helps me to draw a diagram and write how many choices I have for each position in the diagram, and I'm going to show you what I mean by that. I am also going to be giving you the formula so that you don't always have to draw a diagram, but even with the formula, sometimes I find that drawing the diagram is really helpful. So for example here, Katniss is packing her dresses into a trunk to go on tour, and she's also hoping that they don't burst into flame while she's on the train. If she has 10 different dresses, how many ways can she layer them in her trunk? Okay, so look here, I've got my little trunk here, and she's going to layer them in her trunk. She has 10 dresses. The thing here is, oops, I forgot to make things easier on myself here. Hold on one second. I'm going to grab, no, I'm going to do this way. Sorry guys, hold on, I forgot to prep that part. Okay, so look, for the first thing that she's going to put into the trunk, right, she has 10 choices, because she has 10 dresses she's going to put in the trunk. So the first dress that she puts in, she gets to choose from all 10 dresses to decide, right? Now, remember we talked about in the last lesson that idea of how many choices do you have to make? Well, after she's put one dress in, she still has to choose for the next dress to put in. But because she's already put one dress in, she only has 9 dresses to choose from now, right? So after 9, then she needs to put another dress in, and she'll only have 8 dresses from which to choose, right? Because she's already put 1 and a second in the trunk. Okay, so then the next time, right, the next time she'll have 7 dresses to choose from because she's already put 3 in the trunk. And then the next time she'll only have 6 dresses left to put in the trunk, right? And then the next time she'll only have 5 dresses left to put in the trunk. And then the next time, because she will have put even more in the trunk already, she'll only have 4 dresses left to put in the trunk to choose from, right? Again, think about it, every single time she puts one in the trunk, right, it's another choice. Yeah? Every time she's having to choose. And then this time she's still having to choose between the last 2 dresses. Which one does she want to put in next? So she's still going to have 2 to choose from there. Now the last one she doesn't really have a choice, right? She's only got 1 dress left, so in a sense she only has 1 choice to make, or 1 option. So she's choosing out of only 1 object. So since each of these do represent a separate decision to make, this is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is, by the way, sorry about that, 10 factorial, isn't it? Now, you are very welcome to use a calculator to do factorials. You'll see my little calculator here. My calculator actually does not. Oh, it does have a factorial button. It's right here. You see that? So I'm going to type in 10 factorial. Woo! Look at that. 3,628,800 ways that she can pack her trunk. Oh my goodness. Right? So this is, what did I say, 3,600,000, or was it 800? Oh, bother. My memory is not good. 6288. 628800. So that's how many different ways that she can pack her trunk. Hopefully she doesn't spend too much time worrying about that, right? So there are over 3 million ways that she could pack her trunk. Now, Mrs. McGregor has 35 students in her 7th grade class. She is going to choose a class president, vice president, secretary, and treasurer. How many different student governments could she choose? This one's a little different because this time we are looking at it from the point of view that, excuse me, I'm trying to get into my text box here. Okay, there we go. Because this one I did prep. So look, for the first president position, if she picks that one first and she has 35 students, she can choose any of 35 different students, right? So she has 35 options there. Now that she's chosen the president, she has 34 students available for the next position. Now that she's chosen 2 students, she only has 33 students to choose from, because somebody can't have both positions, right? And then finally she'll have only 32 students to choose from. So because of this, we only multiply 35 times 34 times 33 times 32. And this is one of those ones where it can be super helpful to have the diagram. So I'm going to go 35 times 34 times 33 times 32. And I get, wow, yet again, 1,256,640 different ways that she can choose her student government. So 125664, 125640. So that is how many different student governments she could choose. In case you were wondering, yes, Mrs. McGregor was my 7th grade teacher, but we did not have 35 students in our class. We had a whole lot less than that. Okay, so now the permutation formula, which you might have actually already guessed at, is this. Okay, so how many things do you have to choose from? How many things do you have to choose from? This is n. So in the formula, n is how many things you have to choose from. How many spots or positions that they can be placed in is r. So the permutation formula is n factorial divided by n minus r factorial. So there are n factorial divided by n minus r factorial ways to arrange n things in r open positions. So like if we were to come up at this one here, n would have been 35 because it was the number of students you had to pick from, and r would have been 4 because there were 4 spots to fill. This notation right here, NPR, means n permutation r, or arranging r things when choosing from n things. So the formula is right here. NPR is equal to n factorial divided by n minus r factorial. So if we want to apply this, this is especially helpful when we have really big numbers. Howard has 248 Pokemon cards, but his special collector's case only holds 200. How many different ways can he put his cards in the case? So we're going to use the n choose r formula this time. So it's n factorial divided by n minus r factorial. So the first thing we need to do is figure out what n is. So I'm going to go ahead and start thinking about that. N is the number of things I'm choosing from, which is 248. R is how many spots I have. I hate that it does that, which is 200. So to do 248 permutation 200, I'm going to have to do 248 factorial divided by 248 minus 200 factorial, which is the same thing as to say 248 factorial divided by 48 factorial. Now, this may be too big for our calculator to handle, but hopefully at least you'll be able to see how it gets set up, okay? So we're going to do this in the calculator. 248 factorial. Oh boy, look at that, it's huge. Divided by 48 factorial. Which is still hugely unmanageable. So we're going to say, this actually does scientific notation. So your calculator may do this also, so this is good for you to actually get to see. 4.18, so we're going to type in 4.18 here. 4.18 times 10 to the, now look here, see how the blah 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 and it says e plus 246, that means e to the power of, or 10 to the power of 426. It means exponent of positive 426. So here I'm going to go 426. Yeeks, right? But this is one of the many reasons why we would like to know about scientific notation, is because, you know, here it's really helpful because we can't write something that huge. So basically there's a whole lot of different ways that he could do that. But you can see that if we had done this by hand, we would have had to multiply 248 times 247 times 246 times 245 times 244 all the way until we got to 201. Or sorry, all the way until we got to 49. Ugh. We would not have been able to do that by hand at all. We had to use a calculator to get even anything at all on this. Okay, so that's why we like to do it. I'm going to show you the formula one more time. There it is. Do rely on your calculator to do most of those factorials, especially when the numbers are really big. And here is that that problem set assignment again. So please do make sure to do that problem set before you try to do the quiz. And do feel free to draw pictures as necessary and to use the formula when the numbers are really big. Okay? Thank you.